The next part of the lecture for the settlement and the compaction lecture, it will be calculation of the elastic settlement in case of infinite layer. Suppose I don't have a thickness for the layer. The layer is extended to whatever depth I don't know. We said before that in many cases we can assume that if I have a footing like this, I can just assume that the compressible part beneath the footing will be twice the B. If this is B by L, then I can take this B, go down here to twice the B, and consider that whatever beneath will not be affected. This is one approach. This is possible to use this one, and in this case I don't use the equation that I will be giving now, because I will go back to what we have used before and consider that the area that will settle is I know exactly what is the depth of the layer because I assumed it approximately. But if I want to calculate it using these equations, then I can use this equation instead and not assume any fixed boundaries. So for this case, I have two sub-cases. The first case is to assume that the footing is flexible. The second case to assume the footing is rigid. The equation is the same. The difference will be in a factor that I'm going to use. Here S means the elastic settlement. The elastic settlement that will happen to this footing is equal to Q, which is the stress. B is the small dimension of the footing, B of the footing. Mu is Poisson's ratio. We said that sometimes in some equations we need Poisson's ratio of the soil. And usually we need E, which is the modulus of elasticity. And there is a factor. What is the difference here? There is a factor here. I is a factor. I can get it from a chart like this. I just go with I know what is A and B of my footing. I calculate the value of A divided by B. I just go horizontally, cross this line at a point, and then get IP, which is the value of I that I'm going to use it here in case of flexible footings. In case of rigid footings, the difference will be in the I. Here I can take the value of I to be one of these values depending on my L over B ratio. If L over B is 2, 5, 10, then these will be the values of my I, and I will use the same equation. This is the value of I that is given in the Egyptian code in case you need to use it, and it is given for different shapes, different rigid or not or flexible and so on, depending on the location. Where do you want to calculate the settlement? Is it at the middle part of the footing? Is it at the corner? Is it at the middle? And so on, depending if you have a circle or you have a rectangle space. This is an example. A rigid shallow foundation, and this is the dimension of it in plan, is shown in the figure. Calculate the elastic settlement at the center of the foundation. So I need the settlement at the center of the footing, and here it is. I have different values for E. I have E specific value for this, and then here another value, and here another value. Then in this case I will have to calculate an E equivalent, because I don't have one E. E is different from this and this and this, so I will just multiply the value of E, which is here 8,000, I will multiply it by the depth, and the value, the other value with the thickness, and the third value with the thickness, and divided by the full thickness to get something called E equivalent for me to use it for the portion below the footing. And I will use the same equation, and I will use E, the one I got, which is 8,400, instead of using it for each one. Of course, there was another approach. Instead of using an average value of E, which is to assume that this is one layer, and this is another layer, and this is another layer, and calculate the settlement for each layer alone. Take this layer, and the stress on it is this value. This stress over this thickness, calculate the settlement that will happen. Then take this small layer. For this small layer, I will calculate the new stress that will reach the midpoint of this layer, and then for the other layer I will calculate the stress that will reach the mid value of this layer. Usually, to calculate the settlement of any layer, I need the stress at the midpoint of the layer. So either for quick solution, I just take the average of E, or use each E alone and consider them 3 different layers and calculate the settlement of each layer due to stress at the midpoint of each layer. Then we will go to something called soil compaction. Soil compaction, which is the second part of the lecture, is I want to induce compaction to this layer. I have a layer of sand, of clay, or whatever. I want to compact it. Why do I want to compact it? Because if I compact it now, it will not settle in the future. If I have a sponge and I leave it as it is, and then I bring something heavy and put it on top of the sponge will be compressed. So it's settled. If I remove this heavy thing and put something just immediately in place, what will be the value of the settlement? Nothing, because the sponge is already settled. So if I remove this sponge and this load on top of the sponge and put another load, even if it is a little bit higher, the sponge has already settled most of the settlement, so the remaining settlement will be negligible. So this is the idea of compaction. The idea of compaction is that I have soil particles like this in a space, and in this say I have 50% water and 50% air within this voids. If I compact this, what will happen? This amount will be compressed. Of course, water will not be compressed. So water will remain as it is, but these 50% air, part of it or great part of it will be expelled outside. So what will happen? Soil particles will get nearer to each other. Water will still be there, but the voids has decreased a lot. You will still compacting till you reach that all of the air is expelled and you don't have except water. In this case, your problem will change. It will not act as compaction and settlement. It will act as consolidation, because I now want to expel the water. Expelling the water, it does not depend on the load only. No, it depends on the load, and it depends on the permeability, how water is going to leave this small site. It needs to have ways and paths to go through. So if I have clay, it means that I don't have very good permeability. So in this case, once I expel all of the air, then the remaining may take years to happen. The remaining settlement would take years. That's why we said that there is something called immediate settlement. Immediate settlement is the part that we are dealing here. Anything you put on top is still going down till you find that all the white spaces changed to be blue. In this case, we change to a consolidation case. In the consolidation case, we have to wait for the water. We are under their will. We cannot just push as much as we need. No. Whether you push or you don't push, water will not be expelled except depending on the permeability of the soil. So this is compaction. These are some photos showing you what are compaction on site. This is the equipment, the roller that is used for compaction. It's a this roller, by the way, may be also a vibrator. It may include inside some kind of way to induce vibrations on the soil. So this it is a roller with a heavy roller with vibrator. So once it is going on top of the soil, it is vibrating and compacting the soil, and due to own weight, it is also compacting the soil. This is the same for small area. If I have a small trench, I cannot just put this equipment inside this small trench. So I have to bring this equipment, and in this case, vibration should be higher because I will depend mainly on vibration, because this small equipment, the weight of it is very, very small. So I need something to be very, very strong in vibration. This is another equipment that is used for clay. You see here that you have lots of studs similar to your football shoes. In football shoes you have studs. So the same, you have here some studs, so that once you go on top of the clay, the studs penetrate the soil and pushes the soil, because in clay, as we said, it is very difficult to compress. It consolidates. But to do as much as possible that we can to expel whatever air we can find, then we have to something like increase the surface area so that and push so that air is expelled outside. So this equipment is used for clay, and this is the same equipment but in a different view. So why is compaction is important? We said why it is important, because we are going to induce all of the settlements that is expected to happen before the start of the loading of our building. But sometimes we have to build or backfill. In some cases, we don't just want to compact the surface. Sometimes I have a level of ground and I want to I want this level to be raised a little bit, maybe 2 or 3 meters. So how can I add more soil on top of the existing soil? If I add just soil, with the time it will settle a lot. It will be a catastrophe. Why? Because just adding or dumping soil on top of the natural ground, it means that it can settle a lot. It's not compacted at all. So in this case, I may have to do it to add layers. I will just put a small thickness of layer and then compact it. Put another small layer and compact it, and so on. Usually these layers are between 25 to 30 centimeter maximum. You cannot put this. This is a very important number that you have to memorize it by heart. 25 to 30 maximum. This is the height of the layer. In any site that you go and you find people there dumping soil 1 meter on top of the ground and then compacting the surface, you are not compacting, you are just compacting the first 25 centimeters, but the rest, the remaining 75 centimeters will not be compacted at all. Usually, any equipment that you use for compaction only compacts the first 20 to 25 centimeters. So don't try to put more than that. 30 is the maximum, because 30 will be compacted to 25, so you will end up with 25 centimeter that is very compacted. This is the maximum you can do. In many cases, I go to a site, I find that I have very bad soil. I need to take this soil away because it is very bad, and bring new good soil from another site. But if I bring good soil from another site and just dump it on the ground, then I'm removing a problem and replacing it with a different type of problem. So this is not what I need. I need to compact. In some cases, we just are doing this to adjust levels. I need to adjust levels, so I just compact part of the site and compact the other, and so on, till I reach a different, a specific level. And in many cases, in many sites, I have earthworks. Earthworks like, suppose you have an earth dam, a dam, or anything that needs, you need to construct a road. To construct a road, then you have to build the road using soil material. So this is really what happens. What will happen is that I have something like this. These are, imagine that this is a portion of the soil. Usually at the bottom, soil is good, it is compacted. At the top, it is a little bit loose. And so on. If I add stress on top of this soil, what will happen is that particles will come nearer to each other, and once they come nearer to each other, soil particles start to touch each other. In this case, I am really increasing the shear strength of the soil. Why? Because air and water, they have a shear strength of 0. So if you have lots of voids, then you are reducing the strength of the soil. If you have lots of water inside filling the voids, also water is not doing anything. So if you manage to put particles near to each other, then the shear strength of the soil is increasing. Once the shear strength increasing, also the settlement will increase, because I am inducing all the settlement from the start. I don't have, suppose you have something like this. What future settlements can happen? If I have this type of soil, then I still have this particle can move a little bit below and so on till I get some settlement. But if I have particles touching or bearing on each other, I don't have future settlements to expect. The third thing is decreasing the permeability. Of course, we do not depend on it for decreasing the permeability, but it happens, because if you are reducing the voids, it means that you are decreasing the permeability. But suppose I need to decrease the permeability of a piece of land, I cannot depend on compaction alone. Maybe I would inject grout inside to fill the voids. But anyway, what happens is that the permeability will decrease, but it will not prevent water from passing. Water will still be passing. Here, just a moment. In the in the next part of the lecture, and we are going to study compaction and methods of compaction and how to apply the compaction. But just a reminder for you from what we have studied in the previous previous sections. There are some equations that we have studied, how to calculate gamma bulk, gamma dry, and so on from different soil, from different parameters. These are the equations that we use for calculating this. So they are given equation, you don't have to memorize it, just to understand that there are relations between gamma B, which is gamma bulk, GS, which is the specific gravity, WC, which is the water content, E, which is the void ratio, gamma water, and so on. All of these we can apply. If we have some parameter, we can just apply them in the equation to get the other parameter. So here I can get gamma bulk, and here I can get gamma dry. If I can calculate gamma bulk and gamma dry, it means that I can calculate a lot. I can calculate what is the amount of water that I need to add so that I can reach the maximum, because what will happen when I compact something, the density of this something increases. But what is the value of the maximum density? The maximum density is the location where I reach the maximum compaction. Settlement cannot happen anymore. So if I manage to calculate the amount of water that is needed to reach the maximum dry density or the maximum bulk density, it is important. So this is what we are going to study, charts that we are going to draw, and then from the maximum point we can calculate what is the amount of water we can add to this soil so that we can get the maximum compaction that we need, and so on, how the tests are conducted, and so on, till the end of the lecture. We can stop here, and we will continue next time starting from this slide. Thank you, and see you next time.